Hi everyone, it's Sorkin. Today we are going to implement a hash set without using libraries. So what is a hash set? Hash set it's a collection data structure and it has certain features. The first one is that the uniqueness, it doesn't allow duplicate elements. And the next one is it's unordered, and also the performance-wise, the time complexity of add, remove, and the contains functions are of 1, which means that they are constant. So for example, let's say that we have hash set with the size of 4, and we are adding first, we are calling the add function and we are adding 10, and the next one we are adding 54, next one we are adding 73, and we are adding 8. So we are calling 10 one more time, but we cannot add it because 10 is already in our hash set. How we are going to implement that? Let's go over it step by step. The first step is that we are creating an array of node where node is a linked list. So for example, let's say that we have a class node here and it has two fields. The first field is a value and another one is the node next, which means that it's a single linked list. It points to another node. So let's first start with the add function, and for the add function we are receiving a value which we need to add to our hash set. So we are adding 13, and the first thing that what we do is we are calling a hash function and we are calculating our hash. So calculating a hash is much more complicated, but for the sake of simplicity in this case, let's take that as a modulo of value to size. So size of our hash set is 6, and we are taking the value is 13. So 13 by 6 gives us 1. So we are adding that in the first index, right? In the first index, we are adding a node with the value of 13. So we are calling add function one more time, 17, and again we are taking the modulo, and the modulo of 17 to 6 gives us 5, so which means that we are adding that to the 5th cell in our hash set, in our array. And the next one is let's say that the 61, we are calling 61, and the modulo of the 61 to 6 is 1. So what it means? It means that we have to add that to the same cell where we already have a node. And the first thing that what we do is we are comparing that. If the 13 is equals to 61, if 13 is equals to 61, which means that this is the same node that we are adding. So which means that this is the same node, that this is the same value that we want to add. But in that case we are going to ignore that. But in this case it's not the same node. It's just it's another node. But our hash function gives us the same. Our hash function gives us the same cell where to store it. So in that case, what we do is we are creating another node, which our current node points to that node, and we are adding a new node with the value of 61. So let's go over our steps one more time. The first thing that what we do is we are calculating a hash function, which is again, calculating a hash function is much more complicated, but for the sake of simplicity, we are taking as a modulo of value to size. In that, why the modulo? Because in that case, our nodes will be more evenly distributed in our array. And the next one is that we are finding a cell where to add that node based on the hash function that we have calculated. So for example, in this case, we are calculating 13 to 6, right, which gives us 1, which means that we need to store that in the first cell. And the next one is that if node exists, if we have calculated this, we have calculated a cell, we call the hash function, and we call the hash function, and we have an index where to add our node, but another node already exists there. So if another node already exists, again, as we have seen earlier, what we do is we are comparing the values. If they are the same, then in that case it means that it's the same value, and we are just ignoring that. We are not adding that because our hash map should preserve uniqueness. If it's not, as in case of the 61, then we are adding that as a new node and our current node pointing to that node. So what's the time and space complexity of hash set? For the hash set, by requirement, it should be O of 1, it should be a constant. But if let's say our hash function is our hash function is not optimal, so in one cell we are storing too many too many nodes with the values, in that case, to find our value to when we are calling a contains function, so to find our value, it will go over each node, and in the worst case scenario, our time complexity would be of n. First thing that we do here, we are initializing an array. Let's call it buckets, because one index is a one bucket, and it's the size of the, let's say 1,000. We are taking the 1,000. It's the size of our hash set. And the next one is, let's take a look at our add function. In the add function, we are adding a value here. So first thing that we do, we are calling a hash function, and we are passing our value, which gives us the index where we are going to store our value. And we are checking that that index. If our buckets, if that index is empty, so we haven't added any value there, in that case, we are adding to that bucket, we are creating a new node with the value and adding that to that bucket, to that index. If it's not, if there is already a node, which means that there is a collision. So what we do is we are taking that node and we are comparing the value of that node with our current value. If they are equal, then we are returning. So which means that we are returning from this function, which means that we already have that value in our hash set. If it's not, then we are going over our single linked list, and we are comparing that. If we already have that value, if we already have, then in that case we are just simply returning. So which means that we should not add, we should preserve a uniqueness when we should not add that element twice. So we're just returning. If it's not, once we exit this while loop, so what we do is we have now here our last node, right, which is pointing to null. Instead of pointing to null, our last node now next is pointing to our new node with the new value, because that value is not in our hash set and there is a collision. So we need to add to our single linked list, we need to add a new node. How about the contains function? In the contains function is the same. So we are calling a hash function and passing here value, and we are taking our current node, and we're taking our current node, and we are checking that if we are going over our single linked list, and we are checking that if the current value is equals to our value. If it equals, it means that we have that value in our hash set, and we are returning true. And if it's not, once we exit this while loop, if it's not, which means that we don't have it, and we are returning false here. How about the remove? For the remove, again, we are defining our index by calling a hash function, and we are checking that if our bucket is, if our array is empty in that index, which means that we don't have value to remove, right? So there is nothing to remove. In that case, we are simply returning. If it's not, what we do here is we are checking that the value of the current node with our value of the current node with our value that we want to remove. If they are equal, then in that case, what we do is we are simply pointing to the next node. So for example, let's say that we have two nodes, right, for 10, and we have two nodes, two values in one index, in one bucket, 5 and the 10, and we need to remove 10. So if we want to remove 10, then in that case the index value, right, 10 is equals to 10. So what we do is we are pointing to the next node. So buckets index, which means that in that index we are pointing not to our current node, which is 10, we are pointing to the next node, to 5, right? So we are pointing to 5. That's how we are removing that's why we are removing 10 value of 10, which means that the node with the value of 10 we are removing from our single linked list. If it's not the first node, so what we do is we are defining a current which is pointing to our current node, and we are going over our node until we find that value. So for example, let's say that we have 3 nodes, 10, 12 and 18, and we are going over our nodes, and we find, let's say the node that we want to remove is 12. So we are going current next, and that current next value, let's say, equals to 12, right? Current next value is equals to 12, then that's the node that we want to remove. In that case, current next will point, which means that the 10 will point not to 12, but it will point to next, which means that it will point to 18. So 10 in that case will point to 18, right? And we are going over each node in our single linked list. And if we find that node, then we just simply previous pointing to the 10, pointing to the next, pointing to the node that comes after the node that we want to remove. Okay, what's the time and space complexity of this solution? The time complexity for all three, put, remove, and get, should be O of 1. It should be a constant. But if we have too many collisions, which means that in one cell we are storing too many nodes with for some reason our hash function is not working properly, and we are generating the same hash code, the same hash, the same index for too many values, then in that case, in the worst case scenario, our time complexity would be of n, because we need to go over each node to find our value for the contains function. And the space complexity is of n, because space complexity is of n because it's the number of the nodes that we are adding to our hash set. Java solution is identical. So first thing that what we do is we are initializing two variables, size with the, let's say the size of our hash set is 1000, and we are also initializing array of nodes, and we're calling them buckets because one index is a one bucket. And we are also creating here class node, which has two fields, value and the next. So value is the value that we are storing, and the next is the next node that we are pointing to because it's a single linked list. And we are initializing my hash set by bucket, so we are creating array of node with the size that we have mentioned here, 1000, right? So let's go to our functions. The first function or method add, so we are adding our value. The first thing that we do is we are finding an index by calling a hash function. By calling a hash function, as we have mentioned earlier, we are taking a hash function as a key to modulo of key to size, right? So we are taking the modulo key to size, and that gives us index. So now we are checking in our buckets if our index is equals to null. If it equals to null, which means that this is the first value, that we are adding in that bucket. So which means that our index is, our current bucket is empty, our current cell is empty, so we are creating a new node and adding that to that index. If it's not, so which means that there is a collision, so which means that we already have a value that we have added to that cell. So in that case, what we do is we are taking the first node from that index, and we are checking that if our current value equals to value. So if it equals, so which means that we already have that value there, we already added that value, and we are simply returning. So because we should preserve uniqueness. And the next one is that if it's not, then what we do is we are going over our single linked list, and we are checking that if our current next value, if our value is equals to, if it equals to our value, if it equals, which means that again we have that value, we have already added that earlier, and we are returning from there. So we are returning from the function because we have already added that value earlier. And if it's not, once we exit this while loop, what we do is we are at the last node, and we are adding a new node and pointing from our current node to the new node that we have created. To the node that we have created. And now let's go to the contains function. In the contains function, we are doing the same. So we are calling a hash function. So we are taking from our buckets. So we are finding the index, the current index that is the current index that we have. And what we do is we are checking that if it's so we are going over our single linked list until until it's null, until we don't have any nodes in that single linked list. So what we do is at each step we are checking that if our current value is equals to our key, so which means that it equals to our value. If it equals to our value, then in that case what we do is we are just returning true, because that value is in our hash set. Once we exit this for loop, if we cannot find any value here, if we cannot find that our value is in our hash set, then in that case we are returning false. How about the remove? For the remove, we are removing value, and for the value again we are calculating a hash for that value, and we are calculating a hash, and we are finding an index, and we take the index, and the first thing that we check if our bucket is empty. So which means that if we haven't added any value to that bucket, to that index, then in that case we're simply returning, because there is nothing to remove. If it's not, then we are checking that if our current value is equals to our value. If it equals, then in that case we are just pointing to the next node in that linked list, in the single linked list. So for example, let's say that we have two values, 5 and 10, and we need to remove 10. So we are removing 10, so our bucket index now is pointing to our, not to 10, but it's pointing to the next node, to the 5. So if it's not the first one, if it's not the first node, then we are going over our nodes until we find it. So we are going over our nodes, and we are assigning to current our current node, and we are going over our node until we reach the end of the last node. So at each step we are checking if our current next value is equals to value, so which means that we have found our value, and what we do is we are simply pointing our current next points to the current next. So what it means, so for example, let's say that we have three values, 10, 12 and 18. In this case our current next now is pointing to 12, but we need to remove 12, right? So our current next value, which means that this value, right, current next, which means 12 value, is equals to our value that we want to remove. So in that case, our current next now pointing not to 12, our current next pointing to the current next, which means that it points to the 18, right, to the 18. So now that way we are removing 12 from the single linked list, and we are going until the end of our linked list. If you find our value, we are just removing that node from our single linked list. Okay, so what's the time and space complexity of this solution? For our put, remove, and the get function should be the time complexity should be of 1. As I mentioned earlier, if we have too many collisions, then in that case the time complexity is going to be of n, and the space complexity is of n, because it's a number of the nodes that we are adding, number of the values that we are adding to our hash set. That's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.